So let's start with a really fundamental question. What is data science?
You've definitely heard the term everywhere. I mean, it's been called the sexiest job of the 21st century, which is a lot of pressure. And with all that hype, it's easy to wonder, right? Is data science just a fancier way to say you make charts? Or maybe it's just business analytics with a better marketing team?
Well, by the end of our time here, you'll see it's actually something much more concrete. It's not some vague art form. Think of it as a repeatable blueprint, almost like an engineering discipline, for turning messy, raw data into clear, strategic decisions.
Okay, so to really get it, we need to push past the buzzword and just define it from the ground up. At its heart, data science is a hybrid. It's a blend of three really key fields. You've got math and statistics, which give you the solid theoretical foundation. Then there's programming, which gives us the tools to actually work with data at scale. And, crucially, there's domain expertise. That's what makes sure we're asking the right questions in the first place. The whole point is to weave these three together to find insights that you can actually act on.
Now, this whole process isn't random at all. It actually follows a very clear, structured path, a four-step blueprint, if you will. And that blueprint is what we call the data science lifecycle. Step 1 is data ingestion. This is where you gather all the raw materials. Think of everything from clean databases to messy social media feeds. Next, step 2, data processing. This is the cleanup phase because, let's be honest, raw data is never perfect. Here, we clean it, we transform it, and we get it ready for analysis. Then comes step 3, data analysis. This is the fun part, the discovery phase, where you're hunting for patterns, testing ideas, and forming hypotheses. And finally, step 4, communication. Because an insight is totally useless if it just stays in a notebook, right? This last step is all about translating those findings into clear charts and reports so that people can actually make decisions based on them. To really appreciate what makes this blueprint so different, it's really helpful to compare it to a related field, business intelligence. The biggest difference between them is how they think about time, specifically the past versus the future.
So on one side, you have business intelligence, or BI. BI is almost entirely focused on the past. It answers the question, what happened? It's descriptive. It uses structured, static data to tell you about performance that's already occurred. Data science, on the other hand, is focused on the future. It asks, what might happen? It's predictive, and it uses all kinds of data, messy, clean, whatever, to try and forecast what's coming around the corner. That shift from describing the past to predicting the future, that's really the heart of data science. And that predictive power, it's only possible because of that unique combination of disciplines we talked about. You need the math and stats for the models, you need specialized programming to handle huge data sets, you need advanced analytics like AI and machine learning to build those predictive engines, and you absolutely need that subject matter expertise to make sure the predictions are even meaningful in the real world.
Okay, so this all sounds pretty powerful in theory, but what does this blueprint actually build in the real world? Let's take a look at how it goes from just a concept into something tangible.
You can see these blueprints in action all over the place. A bank uses this process to build a system for faster, more accurate loan approvals. A police department might apply it to predict where crimes are likely to happen, so they can send resources there ahead of time. In healthcare, it's used to identify patients who are at risk before their conditions get worse. And, in self-driving cars, this is the exact process that powers the real-time object detection that keeps the car safe.
So, if you're going to remember just one thing from all this, let it be this. Data science is a systematic blueprint for building predictions about the future using the data we have today.
The key takeaway here is to see data science not just as a collection of tools, but as a structured process. The real value isn't in knowing Python or a specific algorithm. It's in knowing how to follow a structured process to solve a problem. It's really about the blueprint, not just the bricks. We mentioned that data comes in a lot of different shapes and sizes. Tomorrow, we're going to take a closer look at the two main types, structured versus unstructured data.